Right. Good afternoon, everyone. Only 11 so far. Anyways, let's talk about our lesson today. So last week, if you remember, we spoke about levels of testing, right? So we said there are different levels of testing when it comes to testing. And there was a chart we spoke about. Today is the continuation of that. So we look at some of the other levels of testing also, coming from black box, white box to deployment to various other kinds of testing. Now you notice we speak a lot about testing now because this is necessary in order to do quality assurance. Testing is a very, very important aspect of quality assurance. After we talk about testing, we will move on to the quality assurance aspect of the software development, right? So this is where we're looking at some of the quality standards and how we can incorporate that into our software development process so that at the end of the exercise, we have a good quality software. So today we are going to talk about system testing, right? So earlier we talked about unit testing, where we take maybe a unit, as in it can be a function, it can be a package, or it can be a component. So we tested these small pieces. And then today we are going to talk about how you put everything together into a system. So it's a complete system. And how do you test that, right? So we're going to integrate everything together and then look at certain compliance, right? Or specified requirements and see whether they are matching with the compliance or the specified requirements, right? And one of the other important thing is we are testing on what is available on the day of the testing. Right? So we can't be testing that the developer says that will come later. We don't know. We don't have it, right? So we are only testing what is available as of today, as of the day of the testing. That is important when it comes to system testing. So what is system testing, first of all? Normally, once we complete the project, we take it out of the development team and also maybe the QA testing team and give it to a third part, right? It might be another QA team doing something else, not this project, maybe they do some other project. So we give it to a third party and say, look, do the systems testing, right? So their job is to look at the behavior of the completed project. So they are verifying the completed product. Remember, this is the last chance we have before we give it out to the customer. So that is why we are taking it out from our normal development testing team and giving it to outside, or at least in the sense they're also part of the organization, but they're not part of the team. So there may be another separate team checking out the project. And the objective here, see, we assume by the time the system is ready, we assume most of the unit testing is done and all the bugs are fixed. And we also done some integrated testing as well. So integration is done, unit testing is done, and now the entire system is ready. So just before giving it to the client, we give it to our systems testing team. So we assume most of the bugs are fixed now, but there may be something here and there. That is what we are trying to find out, what is missing. And why are we doing this? I said this is done by a separate team, right? So we need to have an independent perspective of the system, not from the developers, not from the standard QA or the testing team, right? So we bring in the customer's perspective here, all right? And it's not the customer, actually. That's why we said independent, but not the customer. Sometimes we might be getting the customer also. There is another process we will see in few slides later. That is a process called beta testing. So beta testing is where we incorporate the client as well. So that can be also done using system testing. So the idea here is to get fresh pair of eyes. Fresh pair of eyes mean new set of people, not the same people coming and looking at the product. So we are looking at the holistic, complete, or realistic oh, okay. Right. And basically a holistic test is what we're looking for. And then we are also doing two very important things. One is the functional testing, other one is the non-functional testing. Both are equally important. And we'll see what is functional, what is non-functional also. And at the same time, we are building the confidence in the product. Now, who wants the confidence? Okay, confidence, first of all, the customer, end user need the confidence. Number two, the marketing team also need confidence, isn't it? So that they know the developers have built the right product which they promised to the client, right? So that confidence is very important. And we also try to reduce the risk of releasing. Now, let's say, for example, during system testing, you find out a certain module is not working. So you can turn that off and then release the rest of the application, right? So you reduce the risk of having any issue at the client side. And having said that, we also need to make sure that this is ready to go to UAT, that is user acceptance testing. Before you give it to the user, final user, you need to make sure system testing is done. Okay. Do not give the system to the customer to do the system testing. That will be a disaster. If customer finds out the bugs, that will be a serious problem. Right. So in a nutshell, system testing is functional testing plus non-functional testing. Okay. Now we are looking at the functional testing so far. What is the difference between functional and non-functional? So the functional testing, as per this table, involves product's functionality. So let's say there is a function called report generation. So does it work? So that's the testing of functional testing. Non-functional testing is involving quality factors. Now, is the report printing within a page, or is it printing within, let's say, the margins of a A4 sheet? Or can I print the report in, okay, for example, in order to print the report, does it take how many minutes? Is it 2-minute work or 1 hour job? Those are non-functional things. And then again, functional testing, you can say failures, right? Due to code, right? So bad code, so there are some issues. Now on the non-functional side, it might be due to architecture. Like say, I'm running it for 10,000 users at the same time, system is crashing, right? So that means architecture has a bad design. The third one is done during unit component integration and system testing phase is the functional testing, whereas non-functional testing comes under the system testing phase. Okay. Now, under system testing, also you can do functional testing, but specifically non-functional testing are done on the system testing phase. So, for the functional testing, you need to know certain domain knowledge. That is, if you're building an insurance application, you need to know about the insurance. All right. Insurance plus a bit of computer software. But for non-functional testing, you also need to have the domain name, domain knowledge, design architecture, and also the product knowledge, because you're testing under severe conditions. Like I said, does it work for 100 customers or 100 million customers, or does it fail at 1 million customers? So those are non-functional testing. And then if you look at the configuration side, for functional testing, it's simple and remains the same. Whereas non-functional testing, we change the configuration depending on the installation. So sometimes, let's say you have a common program that you're running under insurance organization. So then you have a insurance related changes or customization. So things like that. Under ratio of functional testing, so that means focus area, right? How much of functional, non-functional to do. So we can start with say 50-50. 50% functional testing, 50% non-functional testing. But as you go forward, as we sort of mature with the product, it can be 70-30. 70% functional, 30% non-functional. Okay, so we can't sort of confirm the number. We can say this is the right number because there can be various reasons, context, and things like that. So it depends on the situation. Okay, so we can't say exactly this, but then it's good to start with 50-50. And then as we mature, we can reduce the non-functional but increase the functional testing. Right. Now, remember, there is also integration testing that we discussed previously, right? So what is integration testing versus system testing? Now, integration is where you brought in component and you put it together, isn't it? So maybe you're not testing each piece. You're not testing all the pieces together. You're only testing maybe two pieces, three pieces together. You're integrating something and you're testing that, right? Then you're integrating that with something else. And again, you're testing that part. Whereas system testing, you're testing the entire system where all the integrations are done and complete, right? So if you look at the second point, integration test cases focus on interaction between modules. Functional system test cases focus on the behavior of the complete product. Right. Now comes the business vertical testing, BVT. Now, what does that mean? So once you build a program, we may be requiring, this is called the domain knowledge, right? Business vertical or the domain knowledge. So it might be banking, insurance, immigration, asset management, health, anything for that matter. So we try to see whether this application is fitting to the chosen industry. Okay, so there may be some customization required to do to the application, but all that is part of the system testing phase. So we are customizing the product to suit the business. And there is another interesting part here. This is called role-based testing, right? What does that mean? Role-based testing, as we spoke about it briefly earlier, there are roles like say user, supervisor, manager, admin, client, different users. So different users do different things, right? So that is coming under the BVT testing. So there is a business vertical or a domain, and then in that domain, there are certain people or roles that use this software in very different ways. So under BVT, there are three things we need to understand. Number one is customization. Number two is terminology. Number three is syndication. So all three are equally important, right? So what is customization? Customization is that we essentially customize the software with the domain or with the vertical, right? So we look at how the business is flowing, business workflow, and then we change the system to match the workflow. Or we record the workflow and then we build the software according to the workflow of the organization. Say, for example, vehicle registration workflow, right? First, you have to give your, let's say, the current owner's information, then the new owner's information. So first, they will delete or rather alter the current owner. Then they add the new owner, and then they change the let's say number plate of the vehicle to suit the, I think now they don't do that, but earlier there was a number plate for every province, right? So Western province, there's WP, then Southern province, there's SP, things like that. So a workflow like that, right? So we map out our system according to the organization workflow. Number two is terminology. What does that mean? Terminology is about the words we are using. Now, let's take a generic term called email. So if you are using the term email within a loan management system, okay, loan application, this same email is called a claim, right? So the word we have to use is claim, not email. Okay, so the staff at the bank understand whenever you talk about claim. So we can say, okay, here's a claim of this person, or here's a claim of that person, right? And if you look at similar situation in elsewhere, it might be called an application, right? Same email, for example, right? So there is a web form, someone filling the form, and that information goes as an email to, let's say, a marketing person. Now, in our university, we call it a lead. So when you go to SLTC website, fill a form, press the submit button, it comes to the marketing team as something called a lead. So we don't use the word email. We say it's a lead, right? So that is called terminology. And syndication means there may be other people connecting things together, not just us, right? So what do they do? Or can they do that? Can they sort of customize our application as per their requirements, for example, right? So, say for example, this is also known as white labeling. Yes. So they should be able to take our product, plug something in from somewhere, and then make a complete product and sell it to a client. Right? That is called syndication. So these are some of the testing that we need to do. If we are supporting, right? So if we are supporting these things, we need to test these things, and this is called the BVT. Now, how do we do the BVT? Two ways you can do. One is called simulation. So you can simulate the customer requirement and the data and see how it works there. Number two is called replication. Now for this, you take the real customer data, load it to the system and see whether it is working, right? Either way you can do it. So simulation is where you look at the customer's requirement and the business flow, and you try to replicate the way they do it. Whereas under replication, you take the data from the client, load it here, and then run that and see whether it works. Which brings us to our next phase of testing, deployment testing. So under this, there are two very important things we need to consider. Actually, there are two phases. Phase one, by the way, deployment means you've completed the project and you're going to give it to the client now. How do you test it and make sure that everything is fine? Remember, we don't come here first. We went through unit testing, component testing, integration testing, and then we went to the system testing, and then only we come here. All right. So we did a lot of testing and make sure our product is working, and then now we are with the customer. So under phase one, what we do here, if you notice here, we have three servers, right? I mean, two servers here. We have the product under test and then the live system. And then we have the user and then we have the test engineer. So test engineer is recording what the live system is doing and then putting the data into the product under test. Basically is simulating, isn't it? Actual data from the live system is taken and similar machine and configuration are mirrored, and the operation from the user are rerun on the mirrored deployment machine. Okay, so that's one way to look at it. Phase one. So you're taking, you see the arrow here, you're recording what the live system is doing and then applying that to the product under test. Phase two is where you are, again, we have the product under test and then we have the old live system. Okay. Now you see the user is using the new system, right? And then we are capturing the data from the new system and then we are loading it to the old system and see whether this is opposite of the previous one, right? Whether this is working. Okay. So after successful first stage, the mirrored system is made a live system that runs a new product. So if you look at the bottom here, so we take the live system, we look at the mirror system, and then change that to the live system. So here we are getting data from the new system, simulating that on the old system and see whether everything is perfect. Which also I will be talking about it later, comes into something very interesting. This is called the CI/CD pipeline, a very famous concept where testing can be automated in the deployment. So I brought it under the deployment testing because this is part of the deployment. So now to do this, you need a lot of unit test. You can't do CI/CD without these things. Yeah. So you might have unit tests, sometimes even UI test, and then it goes through, vigorous testing and then gets loaded to the staging server. In the staging server, it's another server. We look for performance and load. We do the testing there. And then it goes into a user acceptance. So if the user is okay, then we go to production acceptance. And there may be, disaster recovery systems and whatnot. And only then it goes to the release. Under release also, there are various things like A/B testing, penetration testing, performance monitoring, whatnot. So you see, this is how a typical large-scale software company test their product or release their product. Right? Not test, but release. Okay, so it's a very vigorous system to control or to reduce or minimize the crashing of live servers. Which brings us to another interesting question. Why customers would reject a product? Right? Why would customer reject a product? So number one, implicit requirements like ease of use. So the customer is rejecting because it is difficult to use, right? They may not be able to understand how to do something or how to do something simple is not there. It's sort of difficult. For example, let's say complex way of doing things. And customer requirements keep changing constantly. That's another huge problem. So this is why you need a sign off with SRS and also change request mechanism, right? So if the customer wants to change, there is a mechanism where they need to get approval, give some rationale, and then for you to evaluate how much more time required, are there any other costs involved, and things like that. And also ambiguous requirements and not resolving them with the customer. Meaning if the developers don't understand the requirement properly, that will lead into a problem later as well. So you need to clear any doubt you have before you touch the computer, right? But sometimes the developer understand the requirement, understand the problem, but when it comes to implementation, maybe due to their lack of experience in their coding, they might still do something wrong, right? So that is also possible. And the last point is poor documentation and difficulty in using of the product. So poor documentation is developer's issue. When they start the coding itself, they should have done the documentation. And if they don't do that, that will lead into some rejection by the customer, not because the customer is reading the documentation, but you might need more time, more effort to do the slightest change if you don't have proper documentation. Right. Now, all that time, we said it's testing done by most of the time the development team, right? Or the company who developed the software. Now, when everything is done, we then take the software outside the organization. Okay. So we give it to selected customers. And this process is known as beta testing. Okay. Beta testing is a process of testing an unreleased piece of software with a portion of its intended audience, meaning now is the time we are going to give the software to our real customers. Okay. Now, the thing is, we need to be very careful. We must only give it to the trustworthy people. So if you, for example, look at Microsoft, they have something called the beta program, a beta test program, right? Now you have to sign up for the beta test program. For you to sign up for the beta test program, you got to be a Microsoft certified solution provider. That requires qualified Microsoft engineers in your organization, and for you to also pay a certain membership fee, annual membership fee. Okay, so not everyone can afford it or do it. So once you become a Microsoft development partner, you will have early access to their beta release of the software. So there is a process of this, right? So what are the activities we will be needing for beta testing? Collecting the list of customers and their beta testing requirements. So you don't just give it to everyone. This is not a public release, by the way. Okay. So you need to record who's getting our software. You may do it electronically through a form or something, and then working out a beta program schedule and informing the customer. So we also need to tell the customers, look, our beta version 1 is releasing in July 1st, and it'll be obsolete by 30th of July. Right? So it's a period of time. And then before you release the software, the beta software, you can also release some documentation for them to read and understand as to how to install, what are the things required, and whatnot. And then in order to release, you need it's called the alpha version. Alpha is the one that is coming first, beta comes later. So you need a beta ready, or rather beta version that can be released. Okay, so once you have it, you start rolling it out to the beta testers, one person at a time, right? And then you need feedback. So feedback, sometimes the users are taking it, but they won't give the feedback straight. So we may have to build in a mechanism to collect data automatically. So if system is crashing, the system should send data, maybe it's called a memory dump, back to the server. So we can process it later and find out how it happened or why it crashed. Okay. And then as we move forward with the beta test, we also need a mechanism to let the people know about the other new beta versions coming out. And also incorporate the feedback coming from the beta testing to our final project. Now, this picture explains the beta testing in a very nice, easy to understand manner. So step number 1, sign off an alpha testing, meaning alpha testing done, beta version is going to come out. So number 2 is getting hold of the beta version. Number 3 is environment is ready to release the product. So you need to inform the customers, send them some literature on setting up the computers and whatever. So environment is now ready. And then we also need a mechanism to capture the real-time errors, because we're going to get errors, right? Crashes and whatnot, data dumps. So how are we going to capture that, store that, and process it? Okay. And also last one is how to collect user feedback, maybe through a form nowadays, right? Or within the application itself, or maybe through other developer platforms out there. Okay. So unless you have these 5 steps, you can't get into the beta test. Right. Now, all this time, we were worried about the functional side of our software, isn't it? Unit testing, integration testing, system testing. We were testing to see whether it is compliant with our SRS, is it compliant with our customer requirement, and things like that. Non-functional testing is totally different to the functional testing. Why? This is the reason. So they differ from the functional testing by way of complexity, knowledge required to do this, efforts needed, and then the number of times you need to test the same case, right? So they're different when it comes to functional versus non-functional testing. So repeating of the non-functional involves more time, more effort, and also more resources. So it's not easy. Okay. And also, process for non-functional testing has to be stronger than the functional testing to minimize the need for repetition. Right? So what does that mean? The process for non-functional testing has to be stronger. So that itself shows how complex it can be. All right. Now, here is a bunch of tests that we can run on our system: scalability, performance test, and stress test. So under scalability, we are looking at the parameters as in what are the parameters, maximum limit we are testing when it comes to scalability testing, right? As an example, product should scale up to 1 million recorded or 1,000 users. So let's say, for example, we tested with only 10 people. What about 1 million or 1,000 users, right? That can be the entry criteria. For the exit criteria, so entry is like a little higher than your normal running lines, right? And then exit can be the absolute maximum that you need to hit, right? So 10 million records or 5,000 users, something like that. By the way, these numbers you need to test. These are only examples. And then comes a performance test. So what does performance mean? Response time, throughput, latency, meaning when you press the submit button, how long does it take to process that and then come back to you and say, okay, right? How long does it take? So here are some examples again. Query for 1,000 records should have a response time less than 3 seconds. That can be one entry criteria. Sample exit, query for 10,000 records should have response time less than 3 seconds. You see, both are less than 3 seconds. First one, if we can run 1,000, we are okay. But maximum, we need 10,000 records. Stress testing is where we are stressing the system, right? System when stretched beyond the limit. So we go beyond the limit. We call it spikes, right? Let's say your system is planned to run only 20 clients, but you are now testing with 25 clients. What can then happen, right? Your specification says only 20 can be run, but then now you're testing with 25, okay? And exit criteria, product should be able to withstand 100 clients logic simultaneously. So your application requires a lot more memory processing power because you're processing 100 clients, right? And trying to see how many people give, say, data to work out something from the report. And here is a chart that we can use for scalability testing, right? Now, in this, you can see I have a RAM of 512 megabyte, cache of 200 megabyte, number of users 100, right? And then number of records, 0 to 10,000 records. To 10 to 100,000 record, what happened? So start time, end time, how much hard disk is used, how much CPU is used, how much memory is used, and then how much average time to attend record, add record. And then the summary is. Okay. So same thing here, 10 to 100,000 records. You have to do the same thing. And when you do this, only you will realize at one point system is going to crash, right? So then we need to understand what it is. Right. Part of that is also reliability testing. How reliable is the software, right? So you're pushing the limit, it cannot crash. If it is crashing, then we have a serious reliability problem, right? To find out if the software will work in the expected environment for an acceptable amount of time without deviation. So expected environment is what we are trying to deploy our application. And we are going to load the correct amount plus more also and see how it works. Right? And this requires repetition, repeating of the same test cases again and again and again. So the major specific events are software releases, major software releases like version 8, 9, 10, something like that. Completion of a time box. So let's call a time range where you are given some task and then you're given some timer to work on it. And then a regular time interval, say, now there are no timers. So you say, okay, every Sunday we do this. So every Monday we do this, something like that. Right. So then comes another interesting one, stress testing. What does that mean? Stress are like overshoot time to time. And this level is 300 is a normal load. And you can see normal load is here, 300. Whereas the bouncing happened in the first two incidents. And then there's another one going up again. Right. Which brings me to this slide, because this is the chapter I summarized today, reflection summary. It's 7. This is under levels of testing. Name of the book is Software Quality Assurance. Okay. So what did we cover today? So we looked at systems testing today, and we looked at how systems testing is organized, and what are the things we'll be doing there. We also looked at deployment testing. And of course, you notice deployment testing being the final one. It is not complete without all the previous functional unit testing and integration testing and all that stuff, right? So coming to the end where you are giving now the final software to the client, it all depends on how much work you have done previously.